Okay, then let's start right now. Have you ever wondered about what the guy who first invented the wheel really was up to? Because I don't think that he just woke up and said, okay, woke up in the morning, looked at his watch and said, it's so-and-so 1,000 years BC, it's high time to invent the wheel. I don't think the story goes like this. I would like to think that he was intending to invent the plate. He was just fed up by always burning his hand when he put something nice and hot to eat onto his palm. So he said, this can't be healthy, so I'm gonna make a plate. And he built a very nice prototype. He made it thick and solid, gave it a nice circular shape for symmetry reasons, and polished it so it was really, really flat. And this was a very beautiful prototype. It must have been one of the most beautiful prototypes of prehistorical times. But the system test was a disaster. It worked fine as long as they put bread onto the thing, and it worked perfect with boiled potatoes. No burnt hands anymore. But as soon as they started to pour the soup, everything spilled on the floor. So I'd like to think that there was a friend of his who came to his help in this situation, and he said, why don't turn the thing upright and invent the wheel? Then, okay, our hands and the invention of the plate can wait for some more millennia, but at least we don't have to carry all the loads on our backs. Maybe the story went like this. I'll come back to this, to the wheel a little bit later. Well, I studied mathematics and physics in the early 1980s, and we had the opportunity then to do a Fortran 77 course on the university mainframe. And so it was in the summer of 1982 that I hacked my first lines of code onto punch cards. I soon got away from the punch cards, but I remained in the realm of imperative-style languages for another 30 years. And it was 2 years ago almost now, in the autumn of 2014, that I had the opportunity to take some time out and to invest it into learning new things. Well, then I was really after this. And amongst these was finding out what was so amazing about functional languages. And this was my very first encounter with a functional language, with Lisp and with Clojure. And it was amazingly hard to do for me. I didn't expect this, but as soon as I recovered from the loop recur disease, because in the beginning I started, I used loop recur in any function there was, and soon as I, with the help of the foreclosure cones, by the way, as soon as I could manage to write halfway idiomatic Clojure code, the next question arose, and this was, what would it be like to write bigger programs, not just functions? What does design or architecture feel? Because programming felt very much different to programming, say, in C++ or C before. So when coding, it was different. And the question for me was, is there also a difference in the architecture? So do they still think in objects, or do they use composing of things like they do when they write their functions? And so the best thing to find out was, in my opinion, to start an own project. So my very personal fun project. So with me, if I'm talking about fun, very often geometry and mathematics come into play. So it should be something geometrical, this was clear. And I wanted to build my personal interpretation of what can be seen as the ancient mathematician's all-purpose tool, and this was just something to write on and something to something to draw on and something to draw with. This is still in use, and it was in use in the days of Pythagoras and Euclid. So nowadays we can do this on a computer, and the computer we can make the computer to understand what we are doing. So we can not just only draw shapes, but also make the computer to to interpret this and to give us the algebraic representation of what we are drawing somewhere. I learned that this idea was not entirely new. There are some products out there, like Geometry Sketchpad, for instance, or the more academic GeoRepl, which also gives you algebraic representations of your geometric shapes. But I had a look at it, but I thought, oh, well, these are the things, you can't access them, right, from the outside. You have to think about sophisticated or more or less sophisticated interfaces to get access to these structures. And I wanted to have something with Clojure style, of course, because I wanted to write a Clojure program. And I thought, just having recently learned what a REPL was, I said, okay, I want to have the canvas on one side where I can draw my shapes and have a REPL on the other side, and I want to have those two to interact with each other. I thought this was Clojure refilling, and I started this. And so that's the reason why I named this thing GeoRepl. Geo for geometry and Repl for Repl. I'm going to show you now what I've made out of it. I had some other weird ideas as well, because I wanted to have something, if it came to the drawing side of the thing, I could quite intuitively work with. So I didn't want to have menus and these things where I had to click through and find my path through until I got to the point that I could communicate what I was up to, because I tend to forget what I was up to if I have to search for this in the menus for too long. So I wanted to have an intuitive access to the thing. I wanted to have this. I wanted to start just drawing, and the thing should know what I was up to. Okay, and I tried to implement this, and it's by no means ready. It's still a work in progress, but I think it's mature enough by now that I can show you the main ideas here. What I'm trying to do is risky, thank you. It's a bit risky because this is a live thing, and I have no video or so prepared. So we'll see what comes out of it. I start my jar just with this little starter script, and what I get here is what I call the gallery. There are still some bugs in the thing, and one of these is here. You see, this is really nonsensical. It's the caption is called applet. This maybe has to do with the framework I'm using. Maybe the mistake is on my side, probably, but I haven't yet found the time to really get rid of this. But anyway, I'll show you. I try to be honest and show you where the bugs are in the thing if we encounter them. So this is my little gallery. I have three in my workbench, in my local workbench. I have already 3 drawings, and I could access them here. They appear in this little gallery, iconized and with a frame around it, so I can select them. And in this selection, there's always a first element, which is there by default, which is the empty drawing. And this is the one we choose right now. No, I don't want to have it full screen. Again, it's called applet. I would love to get rid of this and have a full blank canvas, which is the original idea, but maybe I'll manage this in a little while. We'll see. Now, I told you I have no menus here, so I can start drawing. I just do this by clicking with the mouse, and what I get by default is the option to draw a polygon. As long as I don't fix the second point, this is still free and it moves with the mouse. And when I click to some point, then the drawing of the first line is finished. I have set the second point of it, and I get the next line to fix. So there is no polygon in the world which is so nice that it should go on infinitely. So we have to stop this action, right? And to stop it, I wanted to use something where the model was, you see, if you say something, stop that, you make this movement, right? And on this Canva, it would be something I would call dashing. I do this right now, doof, and off it goes. So dashing is just like drawing, only with a certain velocity. Make another line here, and again, dash. So this is one thing I use this dashing for. This is to stop an action that I was doing. Now, I'm performing no action right now. When I dash through something now, it clips, and it cuts, and it clips if it clips. Okay. So you see, we're in the land of fuzziness here, because somehow I have to distinguish the case I'm drawing something and I'm dashing. So there must be some things like thresholds and so. And of course, I have a configuration somewhere where these thresholds are defined. This is a nice thing for the time being. I would think if I develop this further, the first step will be to individualize this. So this can be customer dependent, what is meant by high velocity or low velocity. And in this configuration could include things like, oh, the user is left-handed, or he's preferring this or that mouse device. Then the next point would be to have GeoRepl itself to recognize the user, say by a signature you use at login, not just a real name or so, but any drawing you make to identify it. And then say, okay, this is this and that user, so we try to load his configuration, and we try to see what the user is up to and how successful he or she is when drawing things, how often things are undone or so. And from this, it could set these parameters, these configurations by itself. But this would be future. Okay, I told you about undo. Well, this is the third option I have when dashing. So when I'm in an action and dash, this means finish the action. When I dash through an element, this means cut or clip. If I dash into thin air, it just brings back the old states. See? All right. So the next thing we can do is, we don't always want to draw polygons. This is nice, but it's boring. We want to have other shapes as well. So for instance, a circle. So how do I communicate that I want to have a circle? Just by drawing one. Try this, and I get this circle. This is freehand symbol recognition. And I see I got this center point here. This follows my mouse. And if I fix the center point, I can set a radius, and we are fine. The same holds true for arcs. Well, arcs are a bit similar to circles, you know, in the land of fuzziness. It looks like I can't produce arcs anymore. No. An arc is a circle with a defined start and end point, right? I can set this here, set the end point, and set the radius. We're fine. So these are some things we can do, but okay, it's not so nice just drawing polygons and circles. Let's go for something which at least looks a bit more sophisticated, more like maths. First thing I'd like to do is drawing something which looks like a coordinate system, because many mathematical drawings start with a coordinate system. Thing is, we like to have these lines parallel to the frame. So we have menus here, yes, but context menus. So just by clicking on the right mouse button, I get a context menu here. It knows that I'm about to draw a line. And so the two options I have here is normal polygon mode, which is the default, or orthogonal mode, which produces something like this. And so I can draw my parallel lines, and I stop the action by dashing, as before. So something else we can do, I'd like to have a triangle now, or something or 3 lines that work as a triangle. Well, a triangle is a closed curve, so the end point of the last line should be the same as the start point of the first line. We might draw it here somewhere, and just to guess where it would be right, but since this all will have a mathematical representation later on, we might get into all sorts of trouble by this, so we really have to match this point. One opportunity we had, by what I've already shown you, would be just to let them intersect here and then chop away those 2 parts, this V-shaped part thing. But this is somehow unelegant. So I use something else which I call snapping. Proof. Snapping means I just click on a point and stay within a defined radius, defined again, configuration, for a defined number of milliseconds, which is, I think, one second is my snap time I'm using here. So nice. I've got a triangle here. So the next thing I'd like to do is draw a circle which goes through all the 3 edge points of the triangle. So again, I'm going to draw a circle. Yes, but this will lead me nowhere. I can snap this point, but this is not of a great help because there's no way to get this circle go through all the 3 endpoints of the triangle. So again, I use the context menu, and I see that I have 2 strategies to define a circle. One is the thing I've shown you before, which is the default. This is just defining the center point and then the radius. The second is the 3-point definition of a circle, or circumcircle, which I select this, and you see this shape here has changed a bit, so it expects me now to set a point on the circle. I can snap this one as well. I can snap that one as well. We're there. So, should I try another arc now after the disaster before that? Okay, I can draw a little nice arc, fill it out. We're there. So, you see these little spots here and I think you can't read them so very well because of the resolution, and I couldn't change this to fit, or I could have done, but I didn't want to change this. It's no important information for you, it's just when I make a new shape in GeoRepl, it's given a unique name internally, automatically, it's assigned a name. And the name is composed of a prefix, sorry, pardon my English. It's a prefix which is dependent on the shapes. So for lines, the prefix is ln, for circles it's CIR, and so on. They will be needed a little bit later. Okay, I can make nice drawings on the canvas. This looks a bit more like geometry, but still this has nothing to do with mathematics because we don't have access to the algebraic representation. And I promised you to use the REPL for this. I use the lining REPL we have here, and we can have it to connect to the GeoRepl, which works as a server here, and which listens by the port of 7888. Do if it goes. Okay. Beg your pardon. I get a little cold, sorry. So, I started this REPL. I think most of you have seen this, probably. And I change into the namespace where I have my API, my GeoRepl API at hand. So this is GeoRepl.user. This is the place where my API lives. What can we do here? Well, we have a couple of built-in functions. This is my API, which lets me define new shapes, for instance. You can do this by defining a line, give start coordinates. To ease my job here, I do something really predictable and recognizable for me. I just take a bit of a diagonal. So, what do we see here? Well, on the REPL side of the thing, we see the internal Clojure representation of a line shape, just as I have defined it. A line has a P1 key, a P2 key, which is the start and the end point, some internal nonsense, and this pref, which is the reference point, and the name, which is LN6 here. These are these little marks you see. You can't read probably, but I've talked about this. This is the automatically assigned name. We will need this in the, to access this in the API. Pref is something interesting. This is the reference point. Well, we'll see in a little while why this is necessary. First, I'll show you some other functions of the API, like move. It's obvious what this does. Say 50 and 150. And I'll let it move. I forgot to mention something. You see that this thing is in green. I'm working with a currently selected element, and this has two functions. At first, it shows in green on the canvas, so we always know which is the element we're just dealing with. And by default, every creation function leaves this newly created shape as the selected one in this moment. And if we say move, we don't have to give the shape the move refers to. It's just the currently selected element. So that's why this worked. Okay, we can shrink it a bit. It's always nice. I like shrinking. It's the scale function, and we scale it to 70% of 70% of its original length, and it's done. And you see, this is where the reference point comes into play, because we have some, what we call the transformations of the plane. This is moving, translating, and it's rotation, and it's scaling. Well, moving is obvious. We can move anything by a certain vector. This is no problem. But if we scale something, it's not so easy to say which part or which point of the original drawing should remain in its place, or which is what they call the fixed point. So this reference point is nothing else but the fixed point. So by default, this is for lines. This is set to the P1, to the start point. So this always remains in place, and the same is for drawing, right? But we can change this. Obviously, there's no need to or no use to do a search in this context, because this would produce a new state out of the old one, but in this case, we don't see the side effect of the thing on the canvas. Because if you look at it, we're working in the REPL, and this is the functional part of the thing. So we produce state out of a previous state. This is the side effect side. So we can correspond to this, but I like to think of this as really being side effects of what I'm doing in the REPL. So just to show you the rotation as well, rotate by pi over 4, about-ish, like this. So we can't associate, but we have an API function here, and this is called change. And this is, I think, this is the thing where I have to do most life hacking to produce this at the moment. So, sorry, we say change. It's obvious that we change the currently selected element, which is my little line I've here. It's still the same line as we had before. So, but what am I going to change? This is like a search. I give the key pref in this case, and then I want to have P2 to demonstrate this. I want to change this reference point from the start point to the end point. I need to access this. Okay, I have an access function which doesn't change the selected element, though in this case I'm using the selected element to get the second point, but it might be any other point on the canvas. And this is called show. And I have to give it this name it has. So in this case, it was line 6. If I have, oh, sorry, and something else I have to do, of course, I have to say that I want to have this, this P2 key of this element, oh, so missing bracket. It worked. So you see here that the pref, which is down there, changed to P2. And we see this effect just by rotating again. And now we rotate by P2 instead of P1. This is the thing we can do here. Okay, I've drawn a triangle here. Well, it's not true. I've drawn 3 lines. And to give it this additional meaning of being a triangle, we have to do something about it. And I thought about this and said, okay, I need a shape, which I called compound, which consists of a list, or which contains a list of already existing shapes. Then no new shapes are drawn, so this is a compound where nothing new happens here, but I can access these 3 lines as one unity. I'll do this for this triangle I've drawn here. Say compound, and then it's line 3, line 4, and line 5. You see, this is the reason why I needed these names, these unique names, because this is a way to access the stuff here. I don't, well, you see, these API functions came, well, it was a bit unsophisticated approach, I would say. I just wrote me the API as I needed it. It's not the last word on this. One might discuss things, and I'm quite open for criticism in this point. But it's a way, I've done it for the time being, and it works for me, and it works for those things I've tried to do with it, but maybe later on there appear some other problems and some other ideas that let me change this. So I'm always open for refactoring, which is a nice thing if you're doing Clojure. I found there's no language in the world I have ever seen before. Okay, I've seen only a couple of languages, but refactoring always was really, really painful. And with Clojure refactoring, even large refactoring is, well, yes, it can be painful, but it's just say half a day instead of 2 weeks of pain. So the pain is shorter, it's less. Okay, what we see now, I've created this compound, and as before, we have the automatic selection of the newly created shape, which is this compound, and this is the triangle. And now we can do to the triangle what we have done to the line before. We can say move again, for instance, say 50-50. Easy for me. Can let it shrink by, say, to half of its original size. Scale 0.5, and so on. When I implemented these compounds, I had this in mind. And here we come back to the wheel. I was thinking of compounds being some objects, some new objects like triangles that I wanted to treat as one entity, and it was just a little container for already existing shapes. But when I was thinking about this definition, I said, well, the current drawing, the whole current drawing we see on the canvas there, fits to this definition as well. So what if we treat the whole drawing, or the whole state of the drawing as it is in the moment? Why don't we treat this as a compound? And then we can do the following. If we create, or if we change anything, create something, delete something, move something, we don't just manipulate parts of the thing, we do it the functional way. We create a new state, in this sense, a new compound out of the older compound, with the change we have. And we don't chop it away as we normally do this, but we keep it on a stack. So when I'm drawing here, I have a growing stack, starting with the empty drawing in our case here, and then every state we have is piled on top of the others. The current drawing is always the top of stack element. And this is the way we can do undo, because then just we pop away the top of stack element, we get the next below, and this is a new top of stack. So this is how I implemented undo. So I was up to making something for triangles and things like that, and found a way to do undo and with a little modification redo. That's how I treated my drawing state. And this is something which never happened to me in my whole career before, that I implemented something, and it's, with some little adjustment, it did more than I had expected. I always had the experience that it did less than I had expected, and we had to work hard on it. So I don't know that I'm just, why this is so, if I'm just lucky, or if it's just because Clojure enforces a more abstract approach to things, and finding more abstract solution means that they might be good for something else than the thing you originally had in mind. So this is a bit what I wanted to express by this wheel thing. I wanted to invent the plate, and what I got was the wheel. And the plate into that, if we put a rim out around it. So, yeah, this is the thing. Okay, now what I can do as well is I can build recursive compounds. So I can make a new compound, say it like this, and you see here, this was my old compound I had, and this went by the name CMPND1. So I want to have this compound in the new compound, plus, say, this arc we have here. It went by the name of arc1, div. So you see, the new currently selected element is this shape we have there, this compound. And again, if we now do something like, say, scale, make it a bit bigger, 1.2, then it's enlarged. The whole thing is enlarged. So this is this thing about compounds and these things. There's one last thing I would like to tell you. This whole project uses only Clojure. Just the libraries that go with us, or just the standard libraries, where there is no other software except for Quil. It was mentioned in this earlier talk. So does everybody know Quil of you? So who of you doesn't know what Quil is or have never seen it? Some, okay. There's a library out there, or I'd say it's a framework and a library called Processing, and there is a nice Clojure Repl around it, so it can be easily accessed from Clojure programs. And the framework part of it gives you the typical mouse events, like mouse released, mouse moved, mouse dragged, or mouse clicked. And it gives you some update functions, so it loops around. This is the framework part of it, and there's the library part of it, which gives the opportunity to draw shapes like ellipses and circles and lines and all this. I wanted to avoid to have a Quil application, meaning I like Quil, it's great software, but I didn't want to have a too strong dependency on this. So I defined a minimal set of functions I wanted to have from a renderer. Dozen or so or less. And then the implementation with Quil is just one implementation of this interface. And I have another interface, which is just a dummy interface for testing purposes, for my test cases. Because then I don't want to have to mix up with a framework. It's easier to have a dummy for these purposes. So, and that's the reason maybe if you watched closely, you may have seen that when I rotated things, it went in the wrong way. Because normally we have what we call mathematical orientation. This is counterclockwise. So saying rotate by pi over 4 would mean a half turn to the left from your side. It's that way. But this went clockwise. And moving was a bit weird as well, if you've seen this, because I used the positive number for the y coordinate, but it went down. The reason for this is that, well, for Quil, it holds that this is the same thing as with very many renderers. I think this has more technical reasons that come out of graphical processing. The coordinate system we are expecting normally is the right-handed Cartesian two-dimensional coordinate system, which is x-axis here and y-axis there. But this thing is turned upside down. So the y-axis goes from the upper left corner down. And this is the reason why the orientation of the circles is reversed. I was thinking about doing something about this and to implementing this. And shortly before I was about finding the places where I had to fix this, I thought, no, I don't want this. Because I want GeoRepl to have access to the coordinate systems as well, because in mathematics, or especially in theoretical physics, you very often play with the coordinate systems and you have transformations between coordinate systems. And why not having coordinate systems not as part of the canvas, this should be blank, nothing in it, but part of the drawing. And that's the reason why I left this and I defined it to be no bug, which I first thought was. Okay, this gives me the opportunity to shortly say something about what's next. Okay, while presenting this talk, I found some more or less ugly bugs, and I will have to fix them, and there are some things that can be shaped and all this, but this is the bread and butter business and not very interesting, and I think I will get over and done with this in the next couple of weeks. But there are some design issues I consider to be very interesting. First of all, it's about the compounds. I think the compound concept is much more powerful than what I'm using now. I'm using it for triangles and for drawings, and the interesting part is the drawing. But it could be used to implement things like coordinate systems. Another thing I would like to try and to think about, I have no plan yet, is to have something like vector fields, which would be compounds of other compounds. The compounds would be the vectors in the thing, and I could make up whole fields of these things. I could very well imagine having a dynamic compound, something which can change its shape from one position, from a start position to an end position. And most of all, I would like to think about having complex numbers as compounds. Complex numbers have a nice feature because they have two faces. One face is complex numbers are very much similar to real numbers. You can compute with them just like with real numbers, but they also have a geometric interpretation. And this has to do with two-dimensional geometry on the plane. So this could be a nice thing to visualize complex numbers and what you can do with them. Okay, so this is where the journey begins and where I'm up to at the moment and I'm thinking about. One last thing occurred to me when I was playing with it, I think it was 2 days ago or so. This is really fresh. I thought, well, I always had this in mind, to have a canvas here and a REPL there. But why to restrict myself on a REPL? It's no use to say just that we only can play with a REPL. Any old program could do, which is capable of connecting to a server and which can work with the API. So GeoRepl, as I think, could very well be integrated in other programs, and still these features of interaction between these two things would be maintained. So if I started this as a fun project, and it wasn't really meant seriously, but if there's anyone who can imagine that this might be useful for him or for her, please talk to me. Maybe we can do something about this. And yeah, feel free to talk to me. I'll be around here tonight and tomorrow at the conference. And okay, thank you very much for your attention.